Hello, good afternoon, and good morning, everyone. Welcome to this second webinar of our Java Card Forum 2025 webinar series. I'm Antoaneta, the president of the Java Card Forum, and it's a pleasure to have you join us today. Our speaker is Antoaneta Kondeva of Infineon. She's System Security Architect at Infineon's Digital Security and Identity Group. Antoaneta brings deep expertise in automotive security and embedded security controllers, offering valuable perspective on securing connected vehicles. Today's webinar will explore the advantages of secure element and Java Card technology in addressing the evolving cybersecurity challenges faced by connected cars. Java Card provides an open, interoperable platform that allows multiple applications from different vendors to coexist securely on a single chip, going well beyond the limits of traditional proprietary hardware. You will not be able to ask questions during the presentation. There will be a question and answer session at the end of the webinar when we will open the microphone. Anyway, if you want to post a question into the chat, you can during the presentation, and we will address them at the end of the presentation. With this, Antoaneta, the floor is yours for the presentation.
Thank you, Jean. Thank you for having me here, and thank you for the invitation. The topic of my presentation today is target applications for secure elements in future cars. Next slide, please. So this is the agenda. I will give an overview of automotive trends that are driving future cars. Then potential target applications for secure elements in the automotive domain. The next topics are, I will look more deep in particular applications such as car access, V2X, and plug and charge. So to see what are the cybersecurity requirements of that applications and how secure element can support those. An interesting topic is also the vehicle architecture transition and the usage of the secure element in different vehicle architectures. This will be the sixth topic, and I will end up with some information about global platform activities for the automotive. Next slide, please. So there are three mega trends shaping the automotive market. Those are e-mobility, automated driving, and connectivity. And what is common for all of three of those is the cybersecurity. Cybersecurity is a prerequisite to implement those trends. Next slide, please. So those trends bring additional applications different from the past, and the difference is that to implement those applications, the vehicle is now just as a component of a whole open interconnected system that together can fulfill the requirements of those applications, and the common target is a total user experience. Let us have a look in such system as an intelligent transportation system. There the vehicle needs to communicate with the surrounding infrastructure, to communicate with other vehicles, and the target is traffic efficiency, road safety, and better user experience. But also, in case of payment, the vehicle can serve as a payment device. However, the vehicle is just a component from the whole payment ecosystem. And the target is, again, user experience, better user experience. And there are plenty of other applications like car access, where the user can also share digital keys with friends. But behind the system, the whole system, there is a big ecosystem that is existing. And this is the new for connected vehicles, the new feature. And this leads with this feature, there are the external interfaces to the vehicle. They are increasing, and they have to be secured against attacks. For sure, there are plenty of security solutions. However, they can be clustered in two parts. The so-called security hardened microcontrollers. Here, examples are MCU with embedded HSMs, for example. And the other group is dedicated secure elements. So I will concentrate on the dedicated secure elements, and will speak about possible target application for such a secure elements. Next slide, please. So this is an overview of several applications where secure elements can be applied, starting from the functions that are located to the telematic unit or telematic domain. Such application is eCall using the eSIM for safeguarding cellular connectivity. Here is also the vehicle to X application located for safeguarding the communication between the vehicle and other vehicles or the infrastructure. In the infotainment domain, there is the in-vehicle payment application for securing payment credentials. In the body domain, there are two possible applications. The wireless power charging for trusted charging of mobile devices or in general electronic devices, and also the car access application for providing access to the vehicle. In the power domain, there are also applications such as EV charging or the plug and charge use case, where you can just plug the cable to electric vehicle. The vehicle is authenticated, and the billing process and the power supply are automatically provided. And also the battery passport, another application where the battery data should not be manipulated. So we see here plenty of possible applications, and they have a common that are used a PKI system behind and asymmetric cryptography. And all of them are part of a big ecosystem. Next slide, please. I will go now. I selected 3 of them to look deeper on the cybersecurity requirements of those applications and the concept used, the security concept used. Let us start with the car access. Here, the Car Connectivity Consortium is specifying a system to provide convenient car access to the user. And here the idea is to digitalize the key. The mission of the CCC is to standardize the connected ecosystem around the vehicles and the devices with solutions that combine convenience, security, and privacy protection. On the next slide, there is a comparison of the nowadays access systems and the system according to CCC specification. So on the left-hand side, you see that those are proprietary solutions where there is a one-to-one connection of a key to the vehicle. And on the right-hand side is the standardized vehicle access across devices where digital keys are transferable between devices independent of the brand of the device and also independent of the vehicle OEM. The next slide, please. So what are the security requirements for such a car access application? Those are secure distance bounding, secure authentication, confidentiality of the messages for the key pairing, and freshness of the messages. And the security measures are authentication and authorization based on digital signatures and certificates. Here, the role of the secure element is to provide tamper-resistant storage for all cryptographic credentials and also the authentication of the processing. On the left-hand side, you can see the device side. It could be a phone, it could be a key fob, it could be NFC card. For the device side, the secure element is mandatory regarding the CCC spec. And on the secure element, a secure element is storing the credentials, but is also executing the digital key applet. For the vehicle side, the usage of the secure element is not mandatory. However, we see plenty of interest also from the vehicle manufacturers to use secure element also for the vehicle side for that application. Also for the same role, storing the credentials and executing the authentication processing. So that was the car access application. The next application on the next slide is the vehicle to X communication use case. So here we have also for that application the high requirements on security. And those are integrity, authenticity, and privacy. The communicating partners in such a system shall trust each other. And the why V2X is to improve road safety and to increase also the traffic efficiency. Here, there is also a need to securely store private keys. Next slide, please. The role of the secure element is the same as for car access, storage of the private keys, and also executing secure execution of the authentication. So you see here how the communication is done. So there is a vehicle, the sender sending messages to the surrounding infrastructure. It could be a vehicle, it could be traffic lights, it could be a pedestrian about the status or some vehicle data, also sensor data. And this message is signed with private key stored in the secure element. And also with this message, the public key of the certificate and the certificate is also sent to the receiver so that the receiver has the public key and can verify the message. On the sender side, the target is the security, and on the receiver side, the target is actually performance. Next slide, please. So a third application, possible application, is the EV charging, a plug and charge use case. There is a standard specifying the communication for plug and charge. This is the ISO 15118-20 actually. And here, the use case is just plugging, connecting the charging station and the vehicle. The vehicle is authenticating against the charging station. User is authenticated according to the contracts that the user have with the power operators. And then the charging and also the billing process is started automatically. So you can, the charging card is a smart card integrated into the vehicle. Here also, the security concept is based on asymmetric cryptography and using digital signatures and certificates. And the role of the secure element is also to provide tamper-resistant storage for the credentials and also the private keys and also the billing process. So we had a look on some applications. On the next slide, I will explain or discuss the different usage of secure elements depending on the vehicle architecture. Namely, they are vehicle architectures nowadays are more domain oriented, meaning decentralized, but there is a transition to a central vehicle architecture in the future, where most of the functions will be deployed on one brain computer. Nowadays, we can see that the usage of the secure element is for dedicated applications, meaning one application is served by one secure element. But in the future, where plenty of the functionality will be stored on one ECU, then a secure element that shall support those applications shall support several applications, meaning that for the future, for the central based architecture, the secure element shall be a platform allowing multi-applications. And this is exactly, next slide, please. Now we're coming to Java Card as a platform. Here is an example of possible secure element based on Java Card for automotive use cases. What we see here is that we need a basis on the operating system basis, implementing all the crypto functionality needed for the applications that are on top. There is still a possibility for so the Java card is free programmable and extendable, meaning that the user can extend the platform by implementing additional applications or applets. And this is important for the automotive domain, where still some proprietary functionality needs to be implemented on top. However, there are plenty of standardized applications. We saw car access, we saw also payment functionality, and G charging is also standardized. And here, what is also needed in addition to the application itself is content management, additional functionality for generating secure channels, and all those specifications actually are already available and provided by global platform for other domains, but they can be reused also for automotive use cases. Example is the specification for a secure channel protocol, and also the possibility to do scripting with the SCP-11C This is important when the vehicle is offline and there should be connection. And there is an update of the OS needed, and this can be done also via scripting. Another functionality that is provided already by the global platform is the applet update specification. So we see here a lot of already specified APIs and functionalities that are provided by the global platform. What the Java Cloud Platform also has to have as a property is to be updatable, because the vehicle is it will be on the road for 15 years in the field. So this is the difference to other domains. And also the crypto could change. It should also be PQC ready, also because of this reason that the vehicle is longer on the road as other devices. The interface, the physical interface here for automotive domain to connect to the host system is usually an SPI interface. So this is we can summarize. Those are some examples for properties that such a secure element for automotive use cases should have. But it's not a complete list. We are still investigating what are other needs from the automotive regarding APIs, regarding functionality in order to be specified. And this we are doing. Next slide, please. In a global platform, automotive initiative, there are plenty of activities that are happening now. We're looking into the requirements for the automotive domain, also the specification and what APIs are needed, what is already provided by global platform, which specification shall be extended. In the secure element committee, we are discussing also the HSM extension or secure element configuration for automotive. There are also discussions for how to certify such a secure elements regarding different certification scheme. For example, to provide accessible automotive profiles in order to certify implementation regarding CCC. Yeah, this was my last slide. If you have any questions, I'm open to answer.
Thank you, Antoaneta. Do we have any question? Maybe we can open the microphone for questions. Karen, did you open the microphone, by the way? Okay, I have a question from my side, Antoaneta, which is concerning, you mentioned there are legacy already installed solution like the HSM, for example, that you mentioned. How are they positioned for this future application compared to the secure element?
Yeah, so Embedded HSMs, they serve different, or they serve different use cases. For example, there the target is performance. So when you need fax execution calculation of some symmetric crypto, then embedded HSM is the appropriate solution for that. Where the secure element is the target by the secure element is security and not necessarily performance. That's why I see that depending on the use case, some solution is more appropriate than another. For another another difference is that the secure elements are usually certified, security certified, and they are giving a concrete attack resistance. Whereas the embedded HSMs, they are not certified.
Okay, and if I take your diagram where you mentioned that there would be, in the end, maybe a couple of secure elements serving the different applications, do you see still space for the HSM, or will the secure element replace the HSM, or they will be together?
Yeah. So there is a lot of discussions in this regard, but I don't see. So they always will exist several different security solutions, as I said, appropriate for the use case. And as I said, for embedded HSM is meant to be used for safety relevant applications where the performance or real-time applications where the performance is very important. And this is not the case for secure element where the security is actually the target. And the embedded HSM is also providing particular security level. However, for I see that different security solutions will be used complementary and working together to secure the vehicle. They are not excluding each other.
Okay.
There is a need for secure storage that is protected against physical attacks and storing long-term keys. For that purpose, secure element is appropriate. But for other cases where session keys, they should be stored also, can be stored also on an embedded HSM.
Okay. I have a question from the chat, which is the following. If you image the evolution of one secure element for one application device to one secure element for an application, would it be more dangerous to compromise one secure element? Then what is the purpose to share one secure element across different applications?
So the secure element is, as I said, is a hardware secured controller, meaning that it's meant to store different keys, and this doesn't depend on the number of application on it. So
I think the question maybe is around if there is less secure element in the end. For example, if there's only one, then it can be considered as a single point of failure.
Yeah, but actually, this is how a trust. This is how a trust should be built. There should be one trusted anchor from where the trustedness is built on, and a secure element is such a trust anchor, giving the trust in the system. So this is the highest security that can be used in the vehicle. So there should be such a trusted anchor, however.
Okay, okay. And talking about several applications, if I look to what you presented, do you think the application would be owned by different, I would say, stakeholders, or only by the car manufacturer, for example? And if there are several stakeholders, then who would manage the secure element and the security domain? I think, for example, if you look to mobile phone, usually there's only the phone manufacturer that has access and can create or manage the security domain. Would it be the car issuer, or do you think there would be a need for a business agreement? How do you see this working?
In case, yeah, this is actually similar to the mobile phone. Yes, I see that the car manufacturer should be managing, will be issuing the secure element. There are some differences depending on the application. So the eSIM is different, where the mobile operator, yeah.
Okay, okay. So that would be the car issuer, I'd say, the car manufacturer that would be in fact in charge of managing the secure element
Yes.
for all the security domain. There's another question on the chat, which is you were talking about a CCC profile at Global Platform. Is this CCC profile for trusted execution environment or also for the secure element?
So for both, there will be plenty of CCC profiles, and each CCC profile will specify a particular security level, or will mandate a particular security level. And according to different applications can be certified to those CCC profiles. So there will be a secure element certified according to CCC profile, and will also get a higher security level than a TE. But for both, there will be CCC profiles.
Okay, and we talked about the legacy HSM, and now we're talking about the TE, the trusted execution environment. There's also some flexibility in the TE that can also host applications securely. How do you see the balance and the evolution of the TE versus the secure element? Will they coexist? What would be the use cases where the secure element is used instead of the TE and vice versa?
I think that they will TE and secure element will coexist, because they they can be also used for different use cases. As I said, usually secure element is used for one-time or event-based applications, such as cars, or such as EV charging, where the TE can be used for also for where the performance is the target, can be used for more performance related applications, like secure onboard communication and so on. This is the same. So the TE is used usually in application processors, But the use cases for TE I see also the same as for embedded HSM for microcontrollers. That's why I say that they will coexist and they will serve different use cases.
Okay. I have another one, which is about the standardization or activities, because this is an emerging field of application. CCC that you presented, which is a card key, is pretty much standardized. What about the other use cases? Are they addressed at standardization level? Is there some kind of interoperability, or is it just proprietary solutions coming up?
No, so the V2X system is also standardized. So in the V2X use case, in this application, actually there are plenty of use cases that can be implemented, but the application is standardized. And for Europe, there is also a protection profile, and the secure elements shall be used. And for EV charging, the application, the plug and charge is also, there is a standard. The application is also standardized. So there are, all those use cases are based on standards.
Okay, okay. So there are protection profiles, and in terms of, for example, applets that do the application also, they are standardized in some kind of bodies, or is it just the protection profile?
For V2X, this is the protection profile. And
okay, so there's no, for example, reference implementation for applets or that or applet specification, for example.
no, like in the CCC, no.
Do we have other question on the chat, or does somebody has a question? The microphone is open. Don't be shy. No question. I have a last one for you. Is it? I would say I don't know if there's such thing, but is it the same kind of secure element we have, for example, in the mobile phone or the application, or are there any specifics for automotive?
Yeah, so in automotive, the secure element shall be automotive qualified, and this is challenging, meaning that also the request is for zero failure rate, and this is very tough. Also, the temperature range for such a secure element in the automotive domain is higher, up to 105 degrees. So the differences are in terms of quality. So this such a secure element cannot be compared with a secure element used for IoT devices. Regarding functionality, I don't see differences.
Okay. Do we have any other question? Or I don't see any question on the chat. Last chance for the audience. Okay, so everything was clear. Thank you, Antoaneta, for this presentation. It has been recorded and it will be posted on the webinar 2025 page. There was a session this morning that was cancelled because there was some connectivity issue. So apologies for those of you that connected this morning, and sorry for the hiccup. So the presentation and the recording will be on the page, and stay tuned. There are further outstanding webinar coming up in the next few weeks, so please feel free to register to them and spread the word. And also, it's a reminder that we have a YouTube channel with the previous webinars, and there's still a lot of time relevant and interesting stuff on this YouTube channel if you want to see the webinars of the past season. With this, thank you everyone for attending, and stay tuned for the webinars to come. Good evening and good afternoon.